Assalamualaikum warahmatullahi wabarakatuh. My name is Syahrul Hakim bin Anwar, student ID 2023415462. Today I'm going to present about the group project. The objective of this project is to identify object with a name that can be applied to each image that will be used to train the model. Each object has their own category or corresponding class that will help the model identify it due to its ability to recognize and extract characteristics from images and base predictions on those characteristics. The convolutional neural network architecture is particularly ideal for this purpose. For the final goal is to utilize the trained model to correctly identify items in previously unseen photos. For the input data, we compose the images of stationery. To be more specific, we divide it into 5 types of stationeries as an eraser, glue stick, paperclip, pencil, and ruler. There are 400 samples in all in the dataset, 100 samples in each of the 5 categories. Every image has a variety of characteristics, including size, shape, color, and texture. The machine learning model will recognize and categorize the stationery type based on those characteristics.
Thank you, Hakim, for explaining about the objective and the input data. So, I will be explaining about the separation of a data. So, the first one is two sets of a data that has been created specifically for this project, which is the training and testing. From this project, 20% of the data is used for testing, while the remaining 80% is used for training. The machine learning module will be trained on the training sets and its performance will be measured on the testing sets. So the second step is by using the training sets, the machine learning and model will be trained to be able to understand the relationship between the data of the characteristics and labels. The trained model's effectiveness will be accessed using the testing set by contrasting its prediction of the photos with the actual labels of the data. So the last step is, and the third step is, since the model is being accessed on the data that it has never seen before, we may obtain a more accurate assessment on its performance by utilizing a multiple testing sets. This makes it a greater possibility that the model will be generalized effectively and produce precise prediction as fresh and untested data. So that's all for separation of data. So I will pass to the next presenter. Thank you.
Thank you, Kai, for explaining about the separation of data. Next, I will be talking about our training phase. We have conducted 10 different experiments with different values of parameters. So this is the first result that we got from the first experiment. We got a 60% validation accuracy, and it takes 13 seconds to complete the first experiment. Next, for the second experiment, we got 70.67% validation accuracy. The increased accuracy is because of the difference of maximum epoch from the first experiment affects the accuracy result. Maximum epoch from the first experiment is 4, and for the second experiment, it increases into 8 epochs. It takes 2 seconds to complete the second experiment. So for the third experiment, we changed the convolution layer into a new size, and the result of the changes is we got 78% validation accuracy, and it takes 2 seconds to complete the third experiment. For the fourth experiment, we changed the convolution to the layers again with the size of 4, and the result of the changes is we got 91% validation accuracy, and it takes 2 seconds to complete the fourth experiment. For the fifth experiment, we changed the convolution to the layer into a new number of filter, which is 16 and 32. And the result of the changes is we got 86% validation accuracy, and it takes 3 seconds to complete the fifth experiment. For the sixth experiment, we changed the convolution to the layer again, with the number of filter of 8 and 32. And the result of the changes is we got 93% validation accuracy, and it takes 3 seconds to complete the sixth experiment. For the seventh experiment, we changed the convolution to the layer into convolution to the layer with the size of 3 and the number of filter of 16. And the result of the changes is we got 89% validation accuracy, and it takes 2 seconds to complete the seventh experiment. For the eighth experiment, we changed the convolution to the layer with the size of 3 and 4, and the number of filter is 8 and 16. And the result of the changes is we got 74% validation accuracy, and it takes 3 seconds to complete the 8th experiment. For the ninth experiment, we changed the max pooling to the layer into 3 stride 2, and the result of the changes is we got 90% validation accuracy, and it takes 2 seconds to complete the ninth experiment. For the last one, we changed the convolution to the layer and max pooling layer into the size of 4 and the number of filter of 8. And for the max pooling, we used 5 stride 2, and the result of the changes is we got 93% validation accuracy, and it takes 2 seconds to complete the 10th experiment. So I will pass to the next presenter. Thank you.
Thank you to my beloved friend. Next, I will explain for the testing phase. We got 84% validation accuracy. The change in convolution 2 layer and the max pooling second layer may affect the accuracy. From all of 10 experiment, the testing got the high accuracy, and it takes 3 seconds to complete the training. To test out the accuracy, we give the AI 4 pictures with a different stationery type and let the AI figure out the type of the stationery. For the first test, we choose a picture of pencil to test out the accuracy. The result from the figure 18 shows 42.6%. We can conclude that it a successful first test. For the second test, we choose a picture of a paperclip to test out the accuracy. The result from the figure 19 shows 94.2%. We can conclude that it also a successful second test. For the test, we choose a picture of an eraser to test out the accuracy. The result from the figure 20 shows 47.7%. We can conclude that it also a successful third test. For the fourth test, we choose a picture of a ruler to test out the accuracy. The result from the figure 21 shows 100%. We can conclude that it is a successful fourth test. For the last test, which is the fifth test, we choose a picture of a glue stick to test the accuracy. The result from the figure 22 shows 99.2%. We can conclude that it is a successful fifth test.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shukri bin Muhammad Saiful Bahri, and I'll be continuing presenting for our group conclusion. According to the experiment, the maximum accuracy is 93% is obtained from experiment 6 and experiment 10, while the lowest accuracy is 60% is obtained from experiment 1. The starting rates, max pooling 2D layer, convolutional 2D layer, and max epoch of 2 is different. The more max epoch, the more accurate AI can distinguish between images, while the average validation accuracy of 82.47, the range of validation accuracy across all experiments was 60% to 93%. This demonstrates that CNN can distinguish between 5 different types of stationary images, even while AI can't yet distinguish between distinct image as well as human can. It's starting to increase as AI technology develops. 93% accuracy is the maximum.